Hey everyone, and welcome to your C# tutorial on constructors. So as you can see, we have Visual Studio pulled up and the boilerplate code ready to go. Let's begin with a quick definition of what a constructor is. So a constructor is a special method that sets member variables and, or runs extra code when an object gets created. Cool. So that's kind of our base definition for what a constructor is. So now let me show you when a constructor gets executed. So a constructor gets executed when we have a class and it gets instantiated. So let's create a class. We'll call this class person. And it'll just be empty for now. So if we create a person, a new person, this method call right here, you can think of as the constructor being called. So whenever we instantiate a new object from a class, the constructor gets called. Now, you might be thinking, well, we have our class down here. Our class is empty. If we're calling the method here, where is the method? Why don't we have that method in our class? Well, that's part of what makes a constructor special, right? A constructor exists in every class, whether you create one or not. If you don't create one, C# will create one behind the scenes and hide it from you. So let's say, why are constructors special? There's actually a couple of reasons, and one is what we just talked about, which is that every C# class gets a constructor. Even if you didn't create one. Create one. C# will auto-generate a constructor for you. And that's what happened here. We created a new instance of our person. C# then, behind the scenes of our person class is creating a constructor for our person class. There are other reasons, though, why constructors are special. So number 2 is constructor method names are the same as class names. And I'll show you an example of this later, but essentially a constructor method signature will look like this. All right, our third bullet point in the list of why constructors are special. Constructors do not have a return type. So this is pretty special because most other methods have a return type, which we've gone over in the past. Fourth bullet point, why is a constructor special? And this point is going to be more of the second part of number 1. So you could think of number 4 sort of like 1 point, B here. When you create a constructor, you lose access to the, start a new line, to the generated constructor. So what this means is that when you create a constructor in C#, you no longer have the auto-generated constructor. So once you create, if you don't create one, C# will give you a free one. Once you do create one, you no longer have access to the previous one. Okay, awesome. So this is sort of our definition of what a constructor is and why it's special. Let's get into making examples of constructors and how you can maybe use a constructor in different situations. Okay, so let's start by filling out our person object or our person class a little bit more. So let's create a public string of, and we'll call it first name. And then let's create a private string, and we'll call this one last name. Cool. So now when we think about accessing these guys, so we want to, to be able to get and set each of these variables. For our public member variable, that's fine. We can, just access it directly. But for our private member variable of last name, that's going to be a little bit trickier, right? We can't directly access our last name variable. So what we can do is we can create public getters and setters, right? So we'll say get last name. I'm sorry, public. Actually, let's restart this. So let's create a public getter for it. We'll say public string as a return type. It'll be called get last name. And it will return this dot last name. Oops. What's that there? This dot last name. Cool. And then, of course, let's also make a setter for it. Of course, the setter returns nothing. We'll say set last name. This will take in a string. Say that we'll give the parameter name, the name of name. We'll call it name. We'll say this dot last name is equal to our parameter of name. Okay, awesome. So we have our setter and getter for last name. So now let's go over how we would set and get these member variables when we use our person object. I'm gonna cut this just so that we can bring it down here and create some space. I'll paste it now. So if we wanted to access our, and this should all be review, right? But if we wanted to access our member variables on our person object, we would have to go person1, first name is equal to Pete. And then if we wanted to access our member variable for our private member variable, we would have to say person1 dot set last name, and then we would pass in the last name of Grappentine. So if we did this way, every time we created a person object, we would have to do this. One of these two options here. We'd either have to access the member variable directly, or we would have to call on the setter to set it, or call on some other method to set our member variables. So this is kind of the cool thing about constructors, is it gives us an option to do this all in one line. So we can do this just using this line here, this object creation. So let's begin by creating our constructor. So as we talked about in bullet point number 2 here, constructor method names are the same as class names. Also, number 3, constructors do not have a return type. So remember that when you're creating a constructor. So to create the constructor, we will just say, we'll make it public, which we don't have to do because it'll be public by default. We can say person, open close parens, and boom, there you go. This is a default constructor, so it doesn't really do anything yet. Let's start with the first name. So we can create our constructor to take in a parameter of string, and we will call this string first name, do an underscore there to differentiate it from the member variable. And inside of our constructor, we will say this dot first name is equal to our parameter first name. So there you go. We have a constructor that takes in a string called first underscore name and assigns it to our member variable of first name. Now, something else you might have noticed is that over here, we have a red squiggly line, meaning that there's an error. And now if we hover over it like we're doing now, we can see this little description that says there is no argument given that corresponds to the required formal parameter first underscore name of the person class. So now if we look at our wire constructors special lists, when you create a constructor, you lose access to the generated constructor. So you'll notice we have an error here now that we didn't have before. That occurred when we created this constructor. So if we delete it, or if I cut it to the clipboard, you can see that our person instantiation is now valid again. We no longer have an error. However, if I paste it again, you should see that, yes, the person class now has an error. So that kind of illustrates this rule 4 here. When you create a constructor, you lose access to the generated constructor. The generated constructor, all it did was give a sort of a placeholder value to each one of these member variables. That's not what we want. We want to give it we want to give our first name member variable an actual value. So now, how we use this constructor is all we do is in between our parentheses here, we just pass in whatever we want our first name to be. So now we can pass in Pete, or we can pass in Dave or whatever. So I'm going to delete these 2 lines here. We'll say it's Dave, and then let's go down to do a console.writeLine, and we will print out our person1.firstname. Cool. Let's run the code and see what happens. It should just say Dave in the terminal. And there it is. It says Dave. Cool. So we know that our constructor is working, right? So when we instantiate the object, we pass in Dave here to the constructor. And what that does is it runs this code down here. This is saying, whenever you create a new person object and you pass in a string as a parameter, we're going to take that string and we are going to assign our first name member variable to the value of that string every time you create an object. Awesome. So now what about our private member variable last name? We can create a constructor for that as well. So we can do it the exact same way. However, what you might notice is that, well, let's just try it. And I'll show you why we can't do it exactly the same way. Let's try to create a string parameter, and we will call this last name. Now we'll say this dot last name is equal to last name. Okay, so now you might have noticed that we have a red squiggly line here. Why is this an issue? Why do you think this is an issue? It's because the method, what they call the method signature, is the same for each of these. Even though we gave the parameter a different name, the computer can't tell. The computer doesn't really, these names are for humans to read. The computer doesn't really read the names so much as it reads the type. And so to the computer, it sees a constructor or a method that takes in a string. It doesn't really read the name of the variable. That's for humans to read. So it looks down here and it sees a constructor for person that takes in a string, and to the computer, these look identical. So we can't do this. If we wanted to set the first and the last name separately, we would have to do it through a setter method. However, we can create a constructor that takes in both a first name and a last name. So to do that, I'm going to copy this, paste it down here, and I will say first name, comma, string, last name. And now you see we don't get the error. Because the computer sees our constructor for the person class, it takes in a string as a parameter and then assigns it to first name. Great. We've created a second constructor now, and it takes in for the person class, and it takes in a string for the first name, but it also takes in a second string for the last name. And the computer is smart enough to know that this two-string parameter method is different than our single string parameter method. And what we can do in here is we can say this dot last name is equal to last underscore name. Cool. So this relationship between a constructor or a method, remember a constructor is just a method that's special, but a method that takes one parameter, and then that same method, but it takes two parameters, that relationship here is called method overloading. And method overloading is when a method has the same name, but takes different parameters. When a method has the same name, but takes different parameters, that method is said to be overloaded. And so this is a way of overloading our constructor. So if we go back up to our person object, we can create a second person. And we'll call this person2. And we'll set it equal to a new person. And this person's name will be Pete. And his last name will be Grappentine. So now we have two separate person objects, but you can see that we're using both constructors. So the constructors both work for the class. So if we do a console.writeLine, we can say person2.firstName. And then we can do a plus, and we'll do a space here. And then we'll do a get last name. And why are we throwing an error here? Oh, I see, because it needs to be. There we go. All right. So let's run this, and we should see in the terminal, we should see the word Dave and then Pete Grappentine. Interesting. Let me try to run this again. Oops. Okay, so there was just a little glitch there. So yeah, we see Dave and Pete Grappentine. Cool. So what's happening is that when we create our first person class here, and we create Dave is being passed in to our new person object, and it's assigning the first name to our first name member variable. Now, when we create our second person object, we are calling a different constructor because of the ability to overload methods. And you can do this with any method, not just constructors. I'm just showing you using the constructor. So in our constructor, this second constructor, we assign first name to the parameter first underscore name. And then we assign our last name member variable to the parameter last underscore name. So both of these constructors are valid constructors. We just are using them differently. Cool. So this was your C# tutorial on constructors and how they're special, and sort of a bonus piece of information on method overloading. You can Of course, do this with any method. You can create the same named method with different parameters, and you can overload that method. It's just very common with constructors. But again, you can do it with any method. So I hope you learned a little something, and thank you for watching.